So now in this video I thought we would just take a quick look at this circuit. I'm not going to get a schematic out or anything, but in case, what we have is a Schmitt trigger inverter, but I'm using the 555 timer right there. So it is a good component to have a built-in Schmitt trigger inverter. You need pin 6 and pin 2 tied together though, because each one of them looks at a separate voltage. So we got a high enough voltage to set the output low. You can see if I turn the trim pot halfway, we got about half of the supply voltage. Output stays low until I drop below about 1/3 of the supply voltage. And there we go, got a connection. Now the output is high, red LED is lit up. Main thing is we drop below about 1/3, a lower input voltage, we got a higher voltage output. And we go halfway again, it's keeping that high output as good as it can. We got to go up to 2/3 right there before the output will go low. So you can see we got a middle ground region. This is called hysteresis, where the output can be either high or low depending on what we last put it into. Now we have to go below the lower threshold to set the output high, and we got to go above the upper threshold to set the output low. So we got to go above about 2/3 supply voltage, that's the upper threshold, or below about 1/3 of the supply voltage, that's the lower threshold. So now all I really want to do is look at voltages in this circuit right there. So set the meter to V, it's auto ranging. I don't have to move the red probe for anything other than high current right there. So I have 6 volts at the supply. You can see when the blue LED is lit up, we got about 7 milliamps of current flowing, and when the red LED lights up, I turn the trim pot to switch the LEDs. So low enough voltage, and for a high output we got the red LED right there. So I'm going to go back to setting it to the blue LED. So that's about 2/3 of the supply voltage, probably a spec higher. I showed the power supply says about 6.1 volts. We do lose a little bit of voltage along the way right there, about a little less than 6.1 right there. So that's why I set it to 6.1 because if I set it to 6 volts it'd say 5.9 something. So there we go. The output is low. It's connected, you know, fairly good to ground right there. 555 timer does a pretty good job connecting to ground. Not as good though when it has to pass current. That's the main thing. But there you can see we got pretty much spot on 0 volts right there without having to pass any current. The current does change it a little bit. Something to be aware of. Not bad when it's low though. As we'll see, it's pretty bad when the output is high. So we'll look at the trim pot voltage right there, about 4.4 volts. So it's above 2/3 supply voltage, which is 4 volts. So high enough input voltage, low output. So now we're going to look at the output voltage when it is high. There we go. So we dropped below 1/3 supply voltage, probably a little bit below 2 volts. You know, voltages don't line up perfectly, but there you can see it's below 2 volts, less than 1/3 supply voltage. That makes sure the output is high. And we'll see that the output voltage is actually 4.6 volts. It doesn't get to the full 6 volts right there, the full positive supply. And it's worse though because of the LED letting current through. So we will measure that. So you can see it's still not 6 volts, 6.1 volts, nowhere near that really, you know, but it's a lot closer than it was when we had the LED. So without any current, it does get quite a bit higher right there. But even with, you know, somewhere around about 12 milliamps of current flowing, you can see how much the voltage drops down there. So I'm using 6 volts. Even with 6 volts across the red LED, 220 ohm resistor would probably be okay. But you know, usually I just use 220 ohm resistors for 5 volts or less. But with the 555 timer, we're not even getting 5 volts across the red LED when the power supply is at 6 volts right there. So 220 ohms is definitely perfectly fine. So now we will also look at the trim pot voltage. Grab the right thing. There we go. So this is an alligator clip that I can clip to the probe, and I crimped it just with a pair of pliers to the other side of this male-to-male breadboard jumper right there. I made another one for the red one. I really like how you can measure stuff in breadboards really easily with this setup. So we will see the output voltage of the trim pot slightly below 2 volts because the output is high, and we can go even lower. Doesn't matter, output will be high no matter what. Now, as long as the output's high, if we set the trim pot about halfway, about 3 volts out of a 6 right there, then the output was high. But I jumped up to 6 to show we got 6 volts there. So we just had to go above about 4 volts to set the output low. Now I'll drop below 2, and there you can see until we got to 2, output was low. Now until we get to about 4 volts, the output will be high. So this middle ground region is hysteresis right there. 4 volts approximately is the upper threshold, sets the output low, and then 2 volts approximately is the lower threshold right there, sets the output high. Main thing to be aware, we got that hysteresis, that middle ground region where middle ground region doesn't matter anymore. Output's going to stay where it was. You have to go across the other threshold. So always turn the meter off when you're done. And I'm going to end it there. So I hope you enjoy. Make sure you check out one of the other videos I'm posting on the screen, and check out links down below. They all help a lot. I'll see you in the next video.